All right, so you're diving into data science with Python. Awesome. But you've probably noticed there's, well, a sea of different libraries out there. Numpy, Pandas, Scikit-Learn. It can get overwhelming fast. So today, we're going to build your essential toolkit, piece by piece, so you know exactly what tool to grab and when. I mean, it really can feel like just a confusing soup of names, right? But I promise you, by the end of this, you're going to have a crystal clear map of this whole world. You'll see how everything connects. So here's our game plan. We're going to start with the absolute foundation. Then we'll layer on the tools you need to structure your data, then some specialized tools for specific jobs, and finally, the fun part, building models. Let's get into it. Okay, first up, Numpy. You gotta think of this as the bedrock. It's the powerhouse that pretty much everything else in the data science world is built on top of. Its whole purpose in life is to be a high-speed engine for math. Numpy isn't about making pretty tables or anything like that, no. It's about one thing, performing calculations on massive arrays of numbers, and doing it incredibly, incredibly fast. So how in the world is it so fast? Well, it's not magic, it's just really smart engineering. See, the guts of NumPy are written in C, which is way faster than plain old Python. It uses these special arrays that let it do math on the whole chunk of data at once, instead of using slow Python loops. And the key rule is, everything in a NumPy array has to be the same data type, which makes it super efficient. In this line of code, get used to it. You are going to see this everywhere. It's the universal signal. When you see NP in a script, you know NumPy's in the house, ready to crunch some numbers. Okay, let's move up a layer. We've got our super fast engine, but now we need a way to work with messy, real-world data. You know, stuff with column names and different kinds of information. And for that, we turn to Pandas. So here's the best way to think about it. If NumPy is the car's engine, Pandas is the car itself. It's the chassis, the seats, the dashboard. It's actually built on top of NumPy, but it gives your data a structure that you'll recognize instantly, a spreadsheet. It's called a data frame, and it is perfect for cleaning and organizing your data. And this table just lays it all out. NumPy is for the raw, nitty-gritty math on arrays, where everything's the same type. Pandas is for your structured data, like from a CSV file, where you might have numbers, text, and dates all mixed together in one table. Pandas gives you all that flexibility, but it does use a little more memory to do it. And just like NP for NumPy, this is the gold standard. Whenever you're about to rustle some data into shape, your first line of code will almost always be importing Pandas as PD. Okay, so we've got our number crunching engine and our data wrangling toolkit. Now let's add a couple of specialists to our toolbox, the kind of tools you pull out for more advanced scientific and statistical jobs. Now, these two serve really different purposes. Scipy is like a high-powered scientific calculator. You use it when you have a complex math or engineering problem you need to solve. Stats Models, though, is all about the why. You use it when you need to know if your results are statistically significant. You're looking for p-values, you're testing hypotheses. It's all about that statistical rigor. And if you peek under the hood of Scipy, you'll see it's really a whole collection of toolkits. It takes the fast arrays from NumPy and then gives you all these pre-built, high-level algorithms for the kind of stuff you'd see in a research lab or an engineering department. All right, our data is clean, it's structured, we've even run some statistical tests on it. Now, it's time for the part everyone gets excited about, making predictions. And that brings us to the absolute workhorse of machine learning in Python, Scikit-Learn. Scikit-Learn is so popular for one main reason. It makes machine learning accessible. It gives you this clean, friendly, and this is the important part, super consistent way to use all the classic machine learning algorithms. And this right here is its true genius. It's this simple, elegant, three-step dance. It doesn't matter what model you're using, a decision tree, a support vector machine, whatever. The steps are always the same. You pick your model, you .fit it to your data, and then you .predict on new data. That consistency makes trying out different models an absolute breeze. But, and this is a big but, it's super important to know its role. Scikit-Learn is your go-to for what we call traditional machine learning on structured, tabular data. Think spreadsheets. When you start working with things like images or audio and need to build those massive, complex neural networks, that's when you graduate to the big guns, like TensorFlow or PyTorch. Phew, okay, we've covered a lot of ground, so let's put it all together on one final slide you can use as a cheat sheet. And there it is, your complete starter toolkit. It all starts with NumPy for the raw speed,
Pandas puts a friendly face on your data. Scipy and stats models let you dig deeper. And finally, ScikitLearn takes all that prepared data and builds predictive models with it. Each tool has its job, and they all work together perfectly.
So that's your map of the landscape. But remember, this whole ecosystem is always growing, always evolving. Which leaves us with a final question to think about as you start your own journey. What comes next? What's the next big problem that's going to need a brand new tool? Thanks for tuning in.